Alright, hello, my name is Mr. Lead, and today we're going to be doing an experiment. And this is an experiment that you can do at home, and that I want you guys to do at home. So, what we're going to be looking at is we're going to be looking at the density of rocks. Now, we've been covering the topic of tectonic plates. The reason why we're looking at density, I'll come at in a moment. But first, let's just do a quick refresh on what density is. What is density? Density is the measure of how packed together something is. So say you had a bunch of people who are all standing really close together like this, and then you also had a bunch of people who were a bit more spread apart. There we go, perfect drawings. Which one of these groups is more dense? That's right, the one that are closer together. Even though, if I add one more there, they have the same amount of people, this one's more dense because they're more closer and packed together. They're probably going to be catching diseases from each other. So, density is not just a measure of the space that a group takes up. It's a measure of how packed something together is. So, let's look at another example of density. I have here a ping pong ball and a rock. Both of these are about the same size. They both have roughly the same volume, okay? But do they have the same mass? If I was to weigh each of these, would they weigh the same? No, they wouldn't. The ping pong ball would definitely weigh less than the rock. I don't even need to weigh it to tell you. I can even feel that. The mass of each of these is different, okay? To work out the density of an object, we need to take the mass and divide it by the volume. So I'm gonna calculate the mass of this rock right here. Let me turn on this thing. Oh, it's got to zero out itself. Give me a moment. All right. So this rock right here, this is actually basalt. This rock of basalt has a mass of 57.65 grams, okay? So mass is measured in grams. Now, how do we work out the volume? How do we work out how much space this rock takes up? Well, to work that out, you can actually use a measuring cylinder of some sort. So right here, I have a beaker. I filled this beaker right to the brim with water. As soon as I put this this basalt rock in, the water is going to be displaced as per Archimedes' principle. What I'm actually going to do is I'm actually going to wrap my rock up in a bit of paper just so I don't scratch the beaker. And then I'm going to drop it in slowly, and we'll see. Oh, come on. Okay, in my first attempt to measure the volume of this rock, it didn't go well because I wasn't able to drop the rock in slowly, and so all the water kind of just poured out, and I wasn't able to catch it in the measuring cylinder. What I'm going to do now, I'm going to lower the rock in slowly because I've now tied it to the rope, and I'm going to hold the measuring cylinder here to try and catch all the water. So we'll see. We're going to see how much water is displaced by this rock, and so the amount of water that's displaced is the amount of water that would have been taken up by space that the rock is now taking up. Okay, so let's find out how much volume this rock has. Okay, now I can see that. Let's see. If I read the meniscus, well, it's best to do it on the table. There was about 12 mils, so 12 mils of water that was displaced by the rock. Now, the thing with water is 1 mil is equal to 1 centimeter cubed. So I actually now know that this rock takes up about 12 centimeters cubed. Okay? I've now found out the weight of the mass of the rock, not the weight, the mass of the rock, and I've also found out the volume of the rock. I can now do a bit of calculations to work out what is the density. All right, here we go. The density is 4.81. And the unit we use, because we have grams divided by centimeters cubed, we go grams per centimeters cubed. That is the density of this basalt right here. Okay. Now, in terms of densities, density is the reason why things float or sink. This ping pong ball here, obviously, we know it floats in water. That's because water has a density of 1 gram per centimeter cubed. Okay? But if an object has a higher density than water, it's going to sink. If an object has a lower density than water, it's going to float, like this ping pong ball here. What we're wanting to find out is the difference between densities of two different rocks. Say that these rocks were now molten. The one that is more dense is going to sink below the other one. This is what happens with tectonic plates. The crust that is more dense is going to sink below the crust that is less dense. So we're going to test two different types of rock and see which rock is more likely to be a rock found in a more dense oceanic crust or a rock found in a less dense continental crust. All right. So I've just tested a piece of basalt. I'm now going to test a piece of granite. And we're going to see the density of a piece of granite. So give me a moment to work out the mass of this granite. All right, so I've just worked out this granite has a mass of 42.14 grams. Now I'm going to do the exact same thing I did with the basalt. I'm going to work out the volume of this granite. I'm going to take off this string I use for the basalt. I'm going to use the same amount of tissue I used for the basalt on the granite, so that I'm trying to make up for any error that the tissue creates. And once again, I'm wrapping it in tissue so it doesn't scratch the beaker. Now, I'm going to slowly lower this, and we'll see how much volume this piece of granite takes up. Okay. All right, so about 15 mils of water was displaced by the granite, which means that the granite had about a volume of 15 centimeters squared. Oh, sorry, 15 centimeters cubed, I should say. Now, I've worked out the mass, I've worked out the volume. I just need to work out the density, and that is 2.81 grams per cubic centimeter. So we now have the density of these two rocks. We know that the granite is a lot less dense. It's got 2.81 grams per centimeter cubed, and the basalt is more dense. It's got 4.18 grams per centimeter cubed. Now, continental crusts and oceanic crusts also have different average densities, and I've written them here. A continental crust will have an average density of about 2.7 grams per centimeter cubed, while an oceanic crust will have an average density higher of 3 grams per centimeter cubed. So, oceanic crusts will generally always subduct under a continental crust because it's more dense. It will weigh down, or not weigh down. It will drop lower than a continental crust. Now, this is because oceanic crusts are generally made of what's known as more mafic materials. It means it's made of more minerals that are generally heavier, such as iron and magnesium, while continental crusts are made of what's known as felsic materials. They're made of minerals that are a bit lighter, like silicon and phosphorus. and the likes of that. So, with our two rocks, which one would you expect to find in a continental crust, and which one would you expect to find in an oceanic crust? All right. I would probably expect more granite to be found in a continental crust just because it matches the density a little more closely than it does to the oceanic crust. And likewise, I would probably expect more basalt to be found here just because it's a lot more dense. So what I want you guys to be doing is to actually take two rocks, any two rocks, find two rocks in your garden, just as long as they're different enough. You don't need to know what type of rocks they are. If you know that one is granite, great, but if you don't, that's fine. I want you to try and hypothesize to begin with. Which one would you expect to find in continental crust, and which one would you expect to find in oceanic crust? And then provide a reason why, like based on what you already know or what you think the rock is made of. And then from that, I want you to actually measure the mass and densities of those two rocks, the mass and volume of those two rocks, and calculate the densities. Measuring the mass is pretty simple as long as you have a set of scales. Now, when it comes to measuring the volume, you might not have a beaker and a measuring cylinder like what I did, but if you have a measuring cup at home that has a bunch of it has a scale on the side, that's all you would need. If this measuring cylinder was bigger, I would actually be able to just drop this rock in and measure the displacement without having to have this beaker as a middleman. But I don't. This beaker doesn't have enough, have an accurate enough scale, so I had to measure the water that flowed out. So I want you to be smart and think about a way that you can measure the volume. Ideally, if you have some sort of measuring cup that's big enough, you can just put the rock in there, and you'll measure the difference in the water displacement. Okay? If you're confused, ask your teacher. Then after that, work out whether or not you'd expect this rock to be more of a continental crust or be closer to oceanic crust. Then there are some more review questions. This entire Prac, by the way, can be found on page 412 of your workbook. And then after that, upload your results onto OneNote and go through the review questions. Okay, thanks guys.